Assalamu alaikum warahmatullah. Let's continue doing the question 4. So the fourth question, we have two functions f and g. They are given by f of x equals root of x and g of x equals 6 minus x. Let R be the region bounded by the x-axis and the graphs of both functions as shown in the figure. Part A, find the area of R. So we are interested in finding the area under the curve, but there are two curves. So the upper function, or the curve itself, it changes over the interval from 0 to 6. So to find the area, this is part A. To find the area of the region R, you have to use two integrals, because the first one goes from 0 all the way to 4, from 0 to 4. Now, the function that we are finding the area under its curve is what? Is f of x, which is root of x dx, plus there is another integral goes from 4 to 6. Now the function we are interested in is 6 minus x dx. So how do we evaluate this integral? Well, we know that this can be written as x to the power of half, right? Now when we integrate, what do we get? X to the power of 3 over 2. I'm adding 1 to the exponent. Divide by 3 over 2 or multiplied by 2 over 3. Multiplied by the reciprocal. This is evaluated from 0 to 4. Plus, well, this is 6x minus x squared over 2. And this is evaluated from 4 to 6. Okay? Or, for the other one, you can use half times base times height, because this is what? This is a rectangle. So half times, what's the base? The base is 2. It's the difference between 4 and 6. And the height is going to be 2. So the answer will be here what? The answer will be 2. So the whole thing's here, okay? The whole thing, you can replace it with 2. And this should give you what? As a final answer, 22 over 3. 22 over 3. This is part A. Moving to the second part B. Okay? It says the region R is the base of a solid from 0 to 2. The cross sections taken perpendicular to the y-axis, rectangles, and the height is 2y. Okay? Right, but do not evaluate an integral expression that gives the volume of the solid. Because the question says perpendicular to the y-axis, we must isolate x in both functions. So here, you've got y equals root of x. That means x equals y squared. And here you have y equals 6 minus x. That means x equals 6 minus y. I isolated x in both. So I'm going to use this one and this one as well. So for part B, the volume is given by the integral from 0 to 2. Look at the graph. We will start from this point up to this point here, from 0 to 2, of the outer minus inner. Which one is, it's far away, or it's farther from the y-axis? It will be the g of x, and the g of x is going to be what? The g of x is going to be 6 minus y, okay, minus the inner function, which will be f of x, which is going to be y squared, right? This is what? This is the width of the rectangle, of the rectangle. Now the height of the rectangle is given by the question to be 2y. So we'll multiply by 2y dy. We don't need to solve it, but at least we need to simplify it. We need to make it shorter. So the volume is the integral from 0 to 2. What's happening here? Let's multiply this 2y Let's multiply this 2y here and here and here as well. So this is going to be 12y minus 2y squared minus 2y cubed dy. This is the answer of part B. Okay, so part C, what does it say? There is a point P on the graph of F at which the line tangent to the graph of F is perpendicular to the graph of G. Find the coordinates of point B. Now, let's find F prime of X, because the question says the slope. So the slope is associated with the derivative, right? It's the same as the derivative. So the derivative of root of x is 1 over 2 root of x. Okay, now let's find g prime of x. G prime of x will be what? Negative 1. Okay, now the slope of the line one second, where is the question here? The slope of the line perpendicular to G is what? We know that if two lines are perpendicular, they have negative reciprocal slope. So we must flip the slope and change the sign. So here, this slope has a denominator of negative 1 over 1. Now, when you flip and change the sign, it will be 1. Okay, so there is a point B on the graph of F at which the line tangent to F is perpendicular to G. That means you have to set 1 over 2 root of x equals to 1. And if you solve it for x, you should get x equals 1 over 4. So at x equals 1 over 4, there is a line tangent to the graph of F and perpendicular to the graph of G. I hope this was clear. This is the third question. Moving on to the fourth. So this is the fourth question. Moving on to the fifth question. Let f of x be 2x squared minus 6x plus 4 and g of x equals 4 cos of 1 over 4 pi x. Let R be the region bounded by the graph of both, as shown in the figure. The region R is the base of a solid. Each cross section is perpendicular to the x-axis. It's a square, right? But do not evaluate. So this is going to be a quick question. So what does it say here? We have an integral. To find the volume, we have an integral running from 0 to 2. Okay, up to this point, from 0 to 2. So it's a square, so it's something square dx. Okay, now the length of the side of each cross section will be the difference between the two functions, this one here. Okay, so the upper function will be the sinusoidal function, the cos thing, and the lower function will be what? Will be the quadratic function. So this is going to be g minus f. G minus f, g of x minus f of x. Okay, we can just write it easily here. So this is from 0 to 2. G of x is 4 cos of pi over 4 x, right? This is g, okay, minus f, and f is 2x squared. 2x squared minus 6x plus 4 dx. This is the volume. Moving on to question 6. It says let R be the region in the first quadrant enclosed by the graph of y equals 2x, y equals x squared as shown in the figure above. Another solid has the same base R. for this solid, the cross sections perpendicular to the y-axis are squares, right? Right, but do not evaluate an integral expression for the volume. So we have to isolate x on both functions. If you divide both sides by 2, you get y over 2. If you take the square root of both sides, you get x equals root of y. So we are integrating from 0 all the way to 4. This is the cross section. So the volume is the integral from 0 to 4. Now the outer one, which will be the square root of y, and the inner one will be y over 2 dy. But this is what? Squared. Do not forget the square, because the cross sections are squares. So, moving on to question 7. Question 7 says, let R be the region bounded by the graphs of y equals root of x, y equals x over 2, as shown in the figure above. We need to find the volume of this solid with cross sections perpendicular to the x-axis, and the cross sections are squares. Find the volume of this solid. Okay, so we are going to integrate from 0 all the way to 4, right, up to this number here. Okay, the upper function will be root of x minus the lower function. It's 1 over 2x, or x over 2, it's the same, right? So this is all squared dx. Okay, so let's use the expansion of this binomial as we explained in the previous video. So the volume equals the integral from 0 to 4. If you square the first one, it will be x minus, or I would like to break it down into more steps. So this is 1 over 2, right? And this is 1 over 2x. This is all raised to the power of 2 dx. Now, the volume is given by the integral from 0 to 4. Let's use the expansion. So this is going to be x minus, if you multiply 2 times the first times the second, 2 times x to the power of 1 over 2 times 1 over 2x plus 1 over 4 x squared dx. So this becomes the integral from 0 to 4 x, we can cancel this 2 with this 2, minus x to the power of half times x to the power of 1 will be x to the power of 3 over 2 plus 1 over 4 x to the power of 2 dx. Now we can go ahead and integrate. This is x squared over 2 minus x to the power of 5 over 2 times 2 over 5 plus 1 over 4 times x to the power of 3 over 3. There is no dx, we just did the integral. Evaluated from 0 to 4. And if you evaluate this one for 4 and then for minus the evaluation of 0, you are going to end up having 8 over 15. So the answer is 8 over 15. The question 8 is a calculator active question, right? So let's talk about it quickly. We have a region R bounded by two functions. Part A, find the area. Okay. To find the area, we will go from 0 to 2 of upper minus lower. Now the upper function right? The upper function is going to be sine of pi x, minus the lower function is x cubed minus 4x dx, and this is going to be equal to 4. This one is sine of pi x, and the lower one is x cubed minus 4x. This is part A. Part B says the horizontal line y equals minus 2. So there is a horizontal line at y equals minus 2. Okay, there is a horizontal line at y equals minus 2. Splits the region into two parts, right? But do not evaluate an integral expression for the area of the part of R that is below the horizontal line. So we are interested now in what? In this area below the horizontal line. Well, we must find now the intersection points between this horizontal line and the bottom function to find which point we should start with and which point we should end at. This point and this point, if you use your graphing calculator, this one will be it is going to be 0.539. 0.539. I'm referring to x value now. This one here, and this one here will be 1.675. 1.675. So for this part, right, for this part, we have the integral from 0.539 to 1.675. Now the upper function is minus 2 minus the lower function, which is the cubic function. This is x cubed minus 4x. Put it in a bracket, okay? This is upper minus lower dx, and this integral is half of the total area. The total area is 4, so this is going to be half times 4, because the question says splits the region into two parts. Well, I don't think it says equal parts, so no, ignore what I said at the end. So you don't need to set it equal to 2, because it didn't say equal parts. It did say two parts, but it didn't mention that they are equal. So this is going to be enough, the integral from this x to that x of this upper minus lower. Okay, so moving on to the next part. Part C says the region R is the base of a solid. For this solid, each cross sections perpendicular to the x-axis are squares. So x-axis and squares. Find the volume of the solid. Well, the volume of the solid, because it says in the perpendicular to the x-axis, so we will go from 0 to 2. We will go from 0 to 2. Upper minus lower, which is sine of pi x, minus the lower, which is x cubed minus 4x, right? All squared dx. Use your calculator here to evaluate. You will get 9.978. This is part C. Well, part D, I've added this picture here just to explain to you what does that mean in part D. It says the region R models the surface of a small pond. All the points in R at a distance x from the y-axis The depth of the water is given by h of x equals 3 minus x. Okay, so as you can see here, if we take a dimension perpendicular to the xz plane, as in the figure, it will be 3 minus x. Okay, find the volume of the water in this in the bunch. So we know that the volume is given by the integral, okay, we will use it from 0 to 2, right, of, it's the area times the depth, right, it's the area times what? The depth. And the area, we just used it in, I think in part A, okay, so this is going to be the integral from 0 to 2. The integral from 0 to 2 sine of, let me just copy it, pi x minus x cubed minus 4x. This is the area. We'll multiply it by the depth given by the question, which is 3 minus x dx. Again, use your calculator to evaluate. Well, this should be a bracket here. This gives you, it should be 8.369. That is part D. Good luck.